Okay, so let's redo and not delete it, the video about using TensorFlow Lite on the Portenta, using digital information, the kind of information you would get from a microcontroller, such as, you know, it's hot or cold, or too hot or too cold. You could do analog information as well, but this thing is going to be about digital. So we'll have 8 digital zeros or 1, and then we'll come up with 4 outputs. Now this is my page of examples, and we're going to go to the TensorFlow section, which has a whole bunch of examples itself. And I'm just trying to simplify this everything, which is pretty complex stuff. Remember to go to raw to copy it, and it goes pretty quick. So copy, I've got a blank file set up here. And let's see if we're on the Portenta. It is, yeah, there's the M7 core and the port, there's COM15. I better check that. And I'm going to get it compiling because it'll compile on and on and on and on. It actually takes quite a while to do this machine learning stuff. They're big programs, right? So what are we doing here? Well, this program is based on a program I made a few years ago. New login here. Oops, shouldn't have done that. And I'm going to go to it. It's Rocksetter TensorFlow JS. And we don't need to see this. And I've got a whole bunch of examples that I made or found or whatever using TensorFlow, but in JavaScript. There's an advantage with JavaScript in that if you have problems, there's so much help online. And everything ends up as a web page. So here's one, you can read this. Basically, it's saying, you know, if you had sensors and 1 bit would be light, 1 bit would be rangefinder, whether there's no one there or someone there. You could do 2-bit information like CO2, where it's too low, it's low, but it's okay. It's high, but it's okay. It's too high. Or 2-bit temperature, same kind of concept. You could do this with an 8-bit bit of information that has a range, or 4 bits, whatever. It's 8 bits. And then it's going to come up with, and this isn't actually accurate. Let me pause. Now these things, the actuators, this is what you get from the machine learning, is actually saying it's one bit again, but it's actually a range. So predefined text, if you get a 1, it sends the text, or anything above 0.5, it would send the text, anything below 0.5, because it's kind of like a percent, 50%, etc. Fan on or off, you could actually have the fan going faster or slower, heat lamp, hotter or colder. Because this is a floating point number, water on or off, or faster flow, or something like that. Anyway, if you want to see the code, the basic simple code, have a look in that box. Typically this machine learning stuff, that's about 2 pages. It's doable, it's understandable. I teach it to grade 10s. What's nice down here is it's made kind of like a web app, showing your training data and your target data. Notice these are all 8-bit and the targets are all 4-bit. These could actually be floating point numbers, but I originally set it up as digital. This runs the whole thing. You could train it a whole bunch. Let's try just doing 100 just to see what happens. 100 batch. I would do like 5,000 if I was really training something. And the important part is over here, you could save to disk. When saving to disk, remember it's going to save 2 things. I would rename it to model.json, and then it'll rename the second one, the binary file, properly on its own. So this is what it does. It's not a very big, you could definitely make it a bigger training thing. And if you were given this input, it's saying to send the text, don't do anything with the fan, turn the heat on, don't do anything with the water, that kind of stuff. We could change this, the input, and see what happens. This time it is, remember, I didn't train that properly because we did it quickly. And then you would save it to disk, and Then we have a problem because it is in the format of TensorFlow JS, which is a JSON file. It's readable, but it's not ready for a C++ Arduino program. So I'll take you to, let's see, we're in examples, we're in TensorFlow. So here's, oops, let's go back a level. In this main folder, I have a converter. And this converter is going to, and here we're going to move away from JavaScript. We're just going to do command line. It's going to, well, basically do these lines and then do the lines below it. But what I'm going to do, I'm going to cheat and go into Gitpod, which is right over here. It's an online Linux computer, and it's all set up. And it takes a while to load, so mine's preloaded. And in my example, it shows you what's going to happen. Here's the model.json from JavaScript, which you can see is just a text file. And it has a model.waits, which is a binary file. Okay. And it's going to convert it into a Keras file. Okay. Which then a new, here's the code that we're going to do. This first line is going to convert it into a Keras file. This second line is going to convert it into a TensorFlow Lite file, which is right there. And the last line is going to take that TensorFlow Lite file and make it into something that can load up on Arduino. Oh, we don't have to know how this works or whatever. What I'm going to do just to show it in action is I'm going to grab this model.json and put it into, if I can, put it into my folder and grab the model.waits and put it into my folder. This is the thing you would get from the web page. And I'm already in my folder. Let's ls just to see if it's there. Yes, it's there. And let's run this AO1. So /AO1 tab. It's ready to run. It's a bash file. And what we're going to look for is whether it makes more files in this folder. So here we go. And right away, it makes the assets and it makes the Keras file. Then it makes the model.tf lite. Then it makes the model.h. Now, if we look at this one, this is readable. Okay. It's called model.tf lite. And if we zip down to the bottom of it, how do I zip down to the bottom of it? Page down. We see kind of an important one to check is the length. And this one's quite small. Now, there is ways you can look at this. There are ways to quantize it, but I'm just on the verge of getting that stuff right. So at the moment, I'm working with smaller models. Now, it looks like this actually ran. I haven't even talked about it yet. And I'm just going to pause. Okay, looking over here, this has finished. We've got something going on the board. So just check my port. Yep, correct port. Serial monitor. Here we go. So I haven't even talked about the program. Sorry about that. What's happening? So if the 8 random inputs are that, then my 4 trained outputs, in the case right now, it's blue. See, it's flashing blue. Right now, it's mainly red and green, which is coming out as yellow, based on that input. That's machine learning. What you do with it is the important part. What these bits are connected to, whether they're sensing light or whether they're sensing water, and what these actuators, what you're doing with this, that's the important part. So let's have a quick look at this. It is TensorFlow Lite, but if you load TensorFlow Lite, it comes up with many, many tabs up here. I like to make my own tabs, and I also like files that you download one file. So first thing is you probably would have what's coming up in a model.h file. This is the thing we used Gitpod to create. And you'll notice this one's a little bit longer than the example one I did on Gitpod. Always a good idea to look at the length. So 3020. You could easily just copy this, create a new tab, and put it there. And that reduces the size of this program. I find lots of people can go from a single page to tabbed quite easy. But if I give my students something with 12 tabs, they're lost and confused. Whereas this is all quite linear. We're calling TensorFlow Lite. This is calling a bunch of other TensorFlow Lite assignments. These ones are for more advanced programs. And then this is very different from TensorFlow Lite. I'm actually doing something for TensorFlow Lite to work. It has to be able to print out some debug information. And unfortunately, each microcontroller could be a little bit different. So my Portenta H7 M7 core, I don't have to do anything, but the M4 core, I have to do this bit of programming. Whereas on the Arduino Chow, there's this little bit of programming. And if your board doesn't come up, then it basically does a program that does nothing until you figure out the correct way to do your program. Then we've got a namespace that's just naming TF Lite. Here's the model setup program, which is calling those numbers, the model.h file. And this is just the function that does it. I just reposition those things. So it's the interpreter. Bunch of stuff bracketed out because I'm not using it. And here's the main model prediction function. I've written in there that the input, this is a pointer, and I'm debating whether just to use the pointer instead of using variables, but at the moment there is an advantage. So my model.predict is just returning what happens when the interpreter doesn't invoke. I prefer the concept model.predict. So here's the Arduino code. Not even really sure if that's needed. The LED built in. I'm actually setting up, I don't even think I'm using that. A random seed based on AO, serial begin. Here we're setting up the red, green, blue onboard LED. Here's the model setup where we're passing the model TF Lite, that thing with all the zeros or all the numbers on it. Now here I'm designing the input, and I'm making an int32 array with what the modulus 2, this thing does is it just makes a number between 0 and 1. It's randomly creating these things, all 8 of them, in an array. And then here, and this is where I could have just gone straight to the pointer, I'm putting that array 0 value, this myo1, into this interpreter ready for the machine learning program. So we do all 8 of those, and then here it is. That's running it. That's running the prediction. That's it. That's all TensorFlow Lite does, is run predictions. Okay, so this is the main thing. It does the prediction. Remember, I had to go to JavaScript, TensorFlow JS to actually design the model. So this is the main thing that TensorFlow Lite does on a microcontroller. Now, our output, it's a floating point. And here I've just grabbed that pointer and put it in there. Once again, I could just work with that. And then I'm turning the lights on. Now, what you do with your microcontroller based on these numbers, you might just have something, a motor that runs based on whatever number comes through. If the number is 0, it doesn't run. If the number is 1, it runs at full whatever velocity. So we're just setting them low. Reminder, the Portenta, the onboard LED is hooked up to 3v3 already. So you have to set it low to ground it so that it turns on. High, setting it to 3v3, since it already has 3v3, it's not going to do anything. It's kind of reversed for other Arduinos. This is green, this is blue, that one was red. So it's just turning the lights on, which you see here at any one point. That's, just below 50%. That one should be red right now, and it is. And then it's printing out the variable predicted needs to be 0 for everything to be good, and everything's good here. That's mainly when you're just starting out with these things. And then it's printing out this all 8 input string, my input 0. So that's printing out that first one. and then 1 and 2 and 3 up to 7. And the 4 predictions red is just my output 0. As I mentioned before, I could have used the pointer there. And for some reason, I went to a new line. It was crashing. Maybe this is just way too much information. So I did a print and then did a print line for the other one. The other one isn't hooked up to anything, but it's still being analyzed. And a reminder, I set this up with very, very minimal data. If we look back here, here's the data. I only, even though I trained it with probably 5,000 epochs, meaning 5,000 times it went through, I only had 1, 2, 3, 4, 5, 6 inputs. Well, you would want thousands of inputs to fully train this machine learning model to be able to have a sense of what to do based on all those inputs. And I've done 8, you could do 12, you could do 16. And these outputs, each one is, so that matches up with this one. There's the input, there's the expected output. There's the, so you have to know what you're doing and train it on what you're expecting. So then it can learn, yeah, machine learning, kind of the concept. Anyway, have a good day.